Hello and welcome to ILO1. At the end of this lesson, students will be able to find the standard deviation of an engineering problem. Now, the standard deviation is how much the data deviates from the mean. In the diagram on the slide, it shows a data set that has a mean value of 50. This is indicated by the blue line. The diagram also shows a standard deviation of 20, which is 20 either side of the mean. Now, standard deviation is denoted by the Greek letter sigma and also the following equation. This equation will be used for the examples later in the slides, and more of an explanation will be given to it then. So you might ask, where is standard deviation used in industry? Examples include experimental design and analysis, quality assurance and calculation of tolerances for many engineering and also other processes, and also to assess the manufacturing performance in the amount that a data set varies from the average from the mean. If you want to check for other example uses in industry, if you type in standard deviation and, for example, engineering in Google, and numerous applications will appear if you search within. Like most of the topics, it's best explained with an example. Example 8.1. Within a hardware store, the table below represents cable roll wire lengths and the number of rolls within the hardware store. So here we have the table. So there are different lengths between 1 and 5 meters, 6 and 10 meters, 11 and 15 meters, 16 to 25 meters, and 21 to 25 meters. And there, listed on the right column, is the frequency or the number of rolls of each cable length. So now what we want to do is we want to find the mean, then we want to find the standard deviation. So, step 1 is always to go and find the mean. So last week we found the mean using the equation mean, also denoted by x bar, is equal to sigma midpoint times frequency over sigma of the frequency. And what this sigma sign means is the sum. So the mean x bar is equal to the sum of the midpoint times the frequency over the sum of the frequency. So like we did last week, the first step that you should do is draw out the table as illustrated below. The first two columns are those that we were given in the question, the length of the cable and the frequency. The next column is the midpoint, and the last column is the frequency multiplied by the midpoint. So the first step that we go and do is to find the midpoint of each group. So if you're unsure how to do that, what you do is you add the two limits together. So for the length of the cable, you add 1 and 5 together, you get 6, and you divide it by 2. So that'll give you a midpoint of 3. Now, to complete the final column, you multiply the midpoint times the frequency. So in this first case, it's 6 multiplied by 3 gives you 18. So pause the video now for a few minutes and calculate the remaining values in the table yourself. So hopefully the values that you found corresponded to those values that are now displayed in the table. The next step is to find the total of the frequency and also the total of the midpoint times the frequency. Adding those up, you have the total of the frequency is equal to 20 and the total of the midpoint times the frequency is equal to 215. So now we have all the values we need to calculate the mean. And as listed above, the mean is equal to the sum of the midpoint times the frequency over the sum of the frequency. So if you take a minute, pause the video and calculate this yourself, you'll get your answer. And this works out to be 215 divided by 20, giving us a mean of 10.75. At any stage, if you're unsure, go back in the video, play it again, and if you still have further questions, feel free to email myself or Glenn, or else ask any of your fellow students in the group there. So now that we've calculated the mean, the next step is to progress to calculate the standard deviation. So we found there in the last slide that our mean was 10.75. We now want to find the standard deviation using the formula there. So as before, the best thing to do is to draw out a table for us to fill by calculating the values as we go along. So the equation denotes sigma is equal to the square root of the sum of the frequency multiplied by x, which is the midpoint, minus x bar, which is the mean. And once you do that subtraction, if you square that answer before you multiply it by the frequency. Then on the bottom we have the sum of the frequencies. So the first column in the table we have the length, the second one we have the frequency, the third column we have the midpoint, the fourth we have f times x, frequency times the midpoint, as we did in the last slide. And now the next column is the midpoint minus the mean. So for the first one, our midpoint is 3, our mean that we calculate is 10.75. So taking one from the other gives us minus 7.75. So just take care now to make sure that whenever you're taking this away that you still maintain the correct sign, as in this case, which is minus, so minus 7.75. So to complete the next column, what you do is you square this answer that we received, so you square minus 7.75. So if you check that in your calculator, you should get 60.06. So notice when you have a minus number squared, so minus by minus, that's where you get the plus answer. Now the final column is taking that answer that we found and multiplying it by the frequency f. So you multiply 60.06 times 6, which gives us 360.36. So what I want you to do now is I want you to pause the video and calculate the remaining values yourself. If you're unsure how we found those top 3 values there, if you rewind the video a bit and play it again. Alternatively, if you want to ask some of your fellow students, hopefully they'll be able to explain to you as well. So now go and complete the remaining values in the table yourself for the rows of the length 6 to 10, 11 to 15, 16 to 20, 21 to 25. So hopefully now you have calculated the values. I'm going to insert them here. The next step we want to do now is we want to find the totals of the frequency, the totals of f times x, the total of the midpoint x minus the mean x bar, which is then squared, and then the total of the frequency multiplied by the midpoint minus the mean squared. So likewise, if you want to proceed now and add up those values for each of the columns listed there. So for the total for the frequency, as we worked in the last slide, it'll be 20. For the total of f times x, it's 215. The total for the midpoint minus the mean squared is 250.8, and the total of the frequency multiplied by the midpoint minus the mean squared is 973.7. So well done at this stage. Now what we have to do is we have to plug the values in as per the equation for the standard deviation. So we found that the sum of the frequency multiplied by midpoint minus the mean squared is equal to 973.7. We also knew from before that the sum of the frequencies was 20. So that gives us the square root of 973.7 over 20, which works out to be the square root of 48.69, gives us an answer of 6.98 for the standard deviation. So well done. Let's do another example to verify our knowledge. So find the mean and the standard deviation of the following data. So we have temperature ranges between 16 and 17, 18 and 19, 20 and 21, 22, 23, and 24 and 25. And the frequency for those are 6, 8, 7, 4, and 5. So within this question, I want you to calculate the mean and the standard deviation. So the formula for the mean, x bar, is equal to the sum of the midpoint times the frequency divided by the sum of the frequencies. And the standard deviation formula is equal to the square root of the sum of the frequency times the midpoint minus the mean squared divided by the sum of the frequencies. So pause the video for a few minutes now and calculate the remaining values yourself in the table. Firstly, entering the midpoint. Secondly, filling the column the frequency times the midpoint x. Then the next column, which is the midpoint minus the mean. Then once you get that column, the next column is the midpoint minus the mean squared. And lastly, the last column is the frequency times the midpoint minus the mean squared. So say take a few minutes and complete the table. Here are the answers. Okay, so the next step now is to calculate the totals. So the total of the frequency, adding up the 5 values, is 30. The total for the frequency times the midpoint is 603. So that gives us a mean of 603 divided by 30 is equal to 20.1. And lastly, now to calculate the standard deviation, we get the sum of the frequency times the midpoint minus the mean squared, which is 219. So therefore we have standard deviation of the square root of 219 divided by 30, which gives us a square root of 7.31. So it gives us our standard deviation answer of 2.70. So well done on calculating that. Now I have a few examples here for you to try yourselves. The resistance in kiloohms of a sample of 40 resistors from a batch was measured as follows. So we have the resistance in kiloohms 1.24 to 1.26 and the frequency is 3, 1.27 to 1.29, the frequency is 4, 1.30 to 1.32, the frequency is 4, 1.33 to 1.35 and the frequency is 10, 1.36 to 1.38, the frequency is 10, 1.39 to 1.41 and the frequency is 5, with a resistance of 1.42 to 1.44, the frequency is 3, and lastly, with the resistance being 1.45 to 1.47, the frequency is 1. So now what we want you to do is we want you to find the mean. I want you to calculate the standard deviation also, and draw the histogram. So for the histogram, note that the sample widths and thus the frequency density are the same. So therefore there's no need to draw the frequency density. The histogram can just be drawn. So have a go at completing the question. If you're unsure of how to complete it, watch examples 8.1 and 8.2 again, and also feel free to check your solutions with your fellow classmates. So for next week's class, we want you to have this completed if you go through and do it now. So bring your solutions with you in next week's class, and Glenn and I will check your solutions to make sure they are correct. Another example, example 8.4. The time to produce a component in a factory was measured 10 times, and the results are shown below. For the top row we have the time in minutes, and the bottom row we have the component number. So what we want you to do is we want you to find the mean. I want you to calculate the standard deviation. So now have a go at completing the question. Pause this video and just say have a go at it. Once again, for reassurance, if you want to watch examples 8.1 and 8.2 again, and also feel free to check your solutions with your fellow classmates. Once again, your solution for example 8.4 will be checked in next week's class. So print out your solution and bring it with you, and then Glenn and I will check them. So this brings to a close learning outcome 1. So now you can find the standard deviation to an engineering problem. So that is ILO1 completed. So well done on completing this. You have now completed ILO1. The next step is now to go to ILO2 video and play it and go through the examples. Thanks very much. Thank you.